Very good morning, all of you. Can you hear me? मेरी आवाज आ रही है आप लोगों को? टेल मी, कौन है आज के लेक्चर को? Let me confirm first. Am I audible to you or not? Yes or no? बोलो जल्दी से. So that we can start the lecture. बहुत दिनों के बाद मिल रहे हैं हम लोग, शायद इसलिए. कौन है लेक्चर को आज? Am I audible? Okay, so in today's lecture we will start our chapter number 2, that is surface chemistry. In चैप्टर 1 का एक टॉपिक हम लोगों का शायद बाकी है. वो टॉपिक जो है वो थ्योरेटिकल टॉपिक है. आप लोग वो रीड करके भी वो कर सकते हो, ठीक है. बट दिस चैप्टर दैट इज surface chemistry, which includes adsorption and absorption phenomena, and different isotherms are there. For example, Friendlich isotherms are there, then BET isotherms are there, then one more isotherm is there. So this isotherm, it is very important. So we will start this chapter. ठीक है? Yes or no? Langmuir adsorption isotherm is also there. So in this today's lecture, we will discuss what is surface phenomena, or what is adsorption. Then we will see the difference between adsorption and absorption. Okay, then we will see the types of adsorption, and we will see the adsorption isotherms. And in today's lecture we will see first adsorption isotherm, that is Friendlich adsorption isotherm. The Friendlich, it is the name of scientist who discovered this isotherm. That's why it is called as a Friendlich adsorption isotherm. ठीक है? And your assignment number 2, maybe tomorrow or a day after tomorrow I will give you assignment number 2. जैसे कि हम लोगों ने assignment number 1 ली थी based on Google form. Same pattern will be there. Multiple choice question will be there. 10 multiple choice question will be there, and you have to submit that test before your टाइम. जो कुछ भी टाइम मैं आप लोगों को दूंगा उससे पहले आप लोगों को सबमिट करना है, ठीक है? ओके, चलो तो shall I start today's lecture? Yes or no? Shall I start lecture? So this is your lecture number 1 of chapter number 2, that is surface chemistry. Correct? This is lecture number 1, surface chemistry. चैप्टर जो है आप लोगों का, that is surface chemistry. ठीक है? तो let us start with the introduction part. First we will see the definition. We will see the definition of surface chemistry. What is this surface chemistry? Surface chemistry means the phenomenon or the interaction which is taking place at the surface of any substance. That substance may be solid, it may be liquid. So whatever the chemical, physical phenomena that are taking place at the surface of that substance, and to study that phenomena, that is called as a surface chemistry. Okay, so let us see the definition of surface chemistry. See here, surface chemistry deals with study of physical and chemical phenomena. It is nothing but the study of physical and chemical phenomena which occurs at the surface of solid liquid, which occurs at the surface of solid liquid, solid gas, and liquid gas interfaces. That means the your phase should be heterogeneous one. For example, solid liquid, solid gas, and liquid gas. So whatever the physical and chemical different interactions are there, different bond formations are there, to study that interactions, to study that bond formation in physical chemistry point of view and chemical point of view, that study is called as a surface chemistry. So this surface chemistry, it has mainly two important terms. कौन से टू इंपॉर्टेंट टर्म्स है? वन इज एडसॉर्प्शन टर्म जो कि आपके स्क्रीन पे है, एंड अनदर वन इज एब्सॉर्प्शन टर्म. So what is this adsorption term? See, adsorption is a surface phenomenon, I have told you. So what is this adsorption? The phenomena of concentration of a molecules of a gas or liquid at the surface of solid or liquid is called as adsorption. So the phenomenon of adsorption or increase in concentration of molecules of gas or liquid at the surface of solid, that phenomenon is called as adsorption. If you see this figure, then you will understand it better. Okay, so here this solid surface is there, this solid surface is there, and these gas molecules are there, these gas molecules are there, and these gas molecule, they concentrate on the surface of the solid, on the surface of the solid. So this solid surface is called as a adsorbent. This solid surface is called as a adsorbent. That means जिसके ऊपर गैस मॉलिक्यूल एडसॉर्ब हो रहे हैं ना, that surface is called as adsorbent. And whatever the gas molecule that are being adsorbed on the solid surface, that gas molecule are called as adsorbent. Please see the difference between these two terms. Adsorbent is gas molecule, that means substance which is being adsorbed, and adsorbent means the surface on which that gas molecule are adsorbed. Okay, so this is the difference between adsorbent and adsorbent. Adsorbent is a place, and adsorbent provides a space to the gas molecule or liquid molecule to accumulate on the external surface of that solid. That substance is called as adsorbent. And gas molecule, liquid molecules जो है वो उसको क्या बोलते हैं? उसको बोलते हैं adsorbent. ठीक है, so please remember this two phenomena. Now this adsorbent solid surface, they have different types, और इसके example जो है वो है activated carbon, activated alumina, zeolites are there, different types of zeolites are there, ion exchange resins are there, and silica gels are there. So the example of adsorbent are activated carbon, activated alumina, zeolite, ion exchange resin, and silica gel. And if you see these examples, then you will come to know that all these examples, 5 or 6 examples I have written over there. So all these examples, they possesses high surface area. They possesses high surface area. Okay, that means what happens due to high surface area, or why this high surface area is present in all these molecules? Because they are porous in nature. They are porous in nature. They have different types of pores. Micropores, they contain micropores, they contain macropores. Okay, so these examples or these molecules, that is activated carbon, activated alumina, zeolite, ion exchange resin, silica gel, they act as adsorbent. That means they can accumulate or they can concentrate the different molecules of gas on their external surface. Okay, zeolite is there. This zeolite is there. Zeolite has a very high surface area, and it is a porous in nature. So zeolite can adsorb molecules can absorb molecules of gas, or zeolite can absorb these molecules of gas. So zeolite can act as a both. It can absorb the gas molecule or liquid molecule, or it can absorb the gas molecule or liquid molecule. Now what is the difference between these two phenomena, adsorption and absorption? We will see this figure. This figure here, adsorbate is there, okay, and these are adsorbed. See here, so this solid surface is called as adsorbent. मैंने आप लोगों को बोला है जो कि solid surface के external side पे ये gas molecule क्या हो रहा है, concentrate हो रहा है. So gas molecule they are concentrating on the external surface, that is called as adsorption. And absorption means, see here, this is absorption. So these both figure, I will write here figure A and figure B, it is for adsorption. ये किसके लिए, adsorption के लिए. And this figure C, I will call it as a figure C, it is for absorption. And if you see this figure carefully, then you will come to know that the molecules, this is for example, this is gas molecule, they all are external surface. In these two figures they all are present on the external surface, but here they are present inside the surface. They are present inside the surface. And in one more type, they are also present on external surface. They are also present on external surface, as well as they are present, or they go into the inside of that substance. So when this condition is there, both it includes this also, adsorption on external surface and absorptions in the inner part of that molecule. That phenomenon is called as absorption. That phenomena is called as a sorption. Okay, so let us see here. Adsorption implies deposition at the surface only. Adsorption implies is the deposition of gas molecule or liquid molecule at the external surface only. And absorption implies, see here, absorption implies penetration into the body of the solid. So in the absorption, there is a penetration of gas molecule or liquid molecule into or inside the body of solid. And इसका very famous example is sponge. Sponge जो है, if you dip that sponge into the water, then what will happen? The water molecule go inside, as well as water molecule can accumulate outside of the that sponge. One more example is also chalk. In writing chalk जो है हम लोगों का, that chalk is also called as a in that in case of this chalk, there is absorption takes place. Okay, and these both adsorption plus absorption, so both phenomenon are present, then that is called as a sorption. Then that substance is called as a, or that phenomenon is called as a sorption. Okay, then out of these different हम लोगों ने जो देखे थे ना, different types of adsorption materials are there. Out of that adsorption material, activated carbon is mostly used in many industries for filtration, for purification and many other purposes. ठीक है, जो हम लोगों ने zeolite देखे थे, ion exchange reagent देखे थे, out of that among these 5 or 6 molecule, activated carbon are mostly used in many industries for filtration and purification and many other purposes. और अब आजकल तो it is हम आप लोगों ने एडवर्टाइज में देखा होगा, तो it is used in that face cream also. एक्टिवेटेड कार्बन है जो कि आप लोगों का डस्ट निकलता है. सो व्हाई दिस दैट एक्टिवेटेड कार्बन इज यूज्ड इन सच एप्लीकेशन? बिकॉज इट हैज very high surface area. It is a porous in nature. Okay, so it is, first of all, it is solid, then it is a porous, and it is a black carbonaceous material with high surface area. So very important property of this activated carbon is it possesses a high surface area. Now next question comes, how to prepare this activated carbon? कैसे prepare करना है? So two different process are there. first process is related to the physical phenomena, that is physical activation, and second process is called as a chemical activation. That means whatever the carbon material is there, that carbon material is activated by physically, and in another method, that is this in the second method, it is activated by using some chemicals. For example, acids, bases, zinc chloride, these chemicals are used to prepare activated carbon. So based on the method used or based on the reagent used, these two types are there. First is a physical activation and second is a chemical activation. So let us start with the physical activation. Again, this physical activation contains two steps: carbonization and activation. Physical activation again contains two types: carbonization and activation. Now in carbonization, what happens? Let us see first carbonization process. In carbonization, what happens? See here, in carbonization, it is the process in which carbonaceous precursor material is converted into the solid char. Whatever the carbonaceous material or precursor, why it is called as a precursor? Because it is a starting material, that's why it is called as a precursor. So carbonaceous precursor is converted into the solid char in inert atmosphere and at very high temperature. So temperature used for this carbonization process is 600 to 700 degrees Celsius and inert atmosphere. So it is very important to it is a physical activation method, carbonization. So in this process, carbonaceous precursor is converted into the solid char in inert atmosphere and temperature required is quite high, that is 600 to 700 degrees Celsius. So this is first method, that is carbonization. Second step is activation. Now in activation, what happens? This activation can be done either physically, so we can activate that carbonaceous metal either physically, chemically, or you can use both process, physical as well as chemical method. And if you have used both processes, then it is called as a physico-chemical activation method. Then it is called as physico-chemical activation method, and most widely used among this method is a gas state which gives high surface area. For example, if you use gas which is having very high temperature, and if you pass that gas through that carbonaceous material, then due to that passing, what happens? There is a development of pores takes place, micropores development will take place, macropore development will take place, and due to this use of gas, that activated carbon has very high surface area. That gas has a very high surface area, and this activation method is carried out at very high temperature, that is 800 degree to 1000 degrees Celsius. This activation is carried out at very high temperature, that is 800 to 1000 degrees Celsius temperature. Okay. Then second method is for the preparation of activated carbon. First we have seen physical method. That physical method contains two steps: carbonization and activation. And second step is that is chemical activation. So in chemical activation, what happens? In this, that is in chemical activation, raw material is impregnated with some chemicals such as acid, base, or zinc chloride. So raw material, whatever the carbonaceous precursor is there, that carbonaceous precursor is impregnated with acids and base, or in some cases zinc chloride is also used, and this process is carried out in inert atmosphere. And the temperature used, so whatever that impregnated material, carbonaceous impregnated material, that impregnated material is heated at 500 to 800 degrees Celsius, and finally that material is washed with distilled water to remove the impurities. And finally, after heating at 500 to 800 degree, that material is cooled, natural cooling is there. And after natural cooling, so why natural cooling is there? Because while natural cooling, what happens? That material, carbonaceous material or activated carbon will get high surface area due to that natural cooling process. And after the natural cooling takes place, what happens? That activated carbon is washed with distilled water. Okay, so these two methods are there to prepare activated carbon. First we have seen physical method. In that, two steps are there: carbonization and activation. And second method is chemical activation. And in chemical activation, what happens? That carbonaceous precursor is treated with different chemicals, for example acid, base. So this use of acids and bases depends upon that material. Okay. and after impregnated with acids or base or zinc chloride, then it is heated at 500 to 800 degrees Celsius, and after natural cooling that metal is washed with distilled water. So this is chemical activation method. Okay, then we will see the types of adsorption and its characteristics, which is very important. इसके ऊपर हमेशा क्वेश्चन रहता है. Distinguish between physical or van der Waal adsorption or chemical or chemisorption. Okay, so if you have pen and notebook, you can write down these types of adsorption and its characters. So I have मैंने क्या किया है, जो types है, दो types है. First of all, adsorption के कौन से दो types है? First type is physical, it is also called as a van der Waal adsorption, and second type is chemical or chemisorption. These two types are there for adsorption and उसके characteristics है. तो मैंने क्या किया है, टाइम सेव करने के लिए मैंने उसको टेबुलर फॉर्म में लिखा है एंड डिस्टिंग्विश करेंगे हम लोग उसको. ठीक है, सो इन केस ऑफ फिजिकल और van der Waal adsorption, first point is adsorbate molecules are held by weak van der Waal forces. So in physical or van der Waal adsorption, what happens, whatever the adsorbate molecule are held by the solid surface are held by a weak van der Waal forces. So the interaction between a gas molecule and solid surface is weak van der Waal forces. That's why it is called as a van der Waal adsorption. This interaction or the bond between gas molecule and solid surface, it is a van der Waal forces, and due to this it is called as a van der Waal adsorption. So first point is, in physical or van der Waal adsorption, adsorbate molecules are held by weak van der Waal forces. Now that first molecule, in case of chemical adsorption or chemisorption, adsorbate molecules are held by strong chemical bond. So here chemical bond is present in between gas molecule and solid surface. Due to this presence of chemical bond, that type is called as a chemical adsorption or chemisorption. Okay, due to the presence of chemical bond, that adsorption type is called as a chemical adsorption or chemisorption. So this is the first difference, or this is the first point, and this is the first characteristics related to their interaction or a bond present between solid and gas. Then second point is, it is irreversible in nature. So this physical and van der Waal interaction, it is irreversible in nature. Why it is irreversible in nature? Because weak van der Waal forces are present, and and you know that these van der Waal forces, they are very weak, so they can break the bond between solid surface and gas molecule, and again there is formation of gas and separate solid molecule will take place. So it is reversible in nature. It is not specific. It is not specific. Not specific means, in the sense, if you have kept any solids object in the atmosphere, then any molecule can adsorb. Any molecule can form van der Waal forces between this solid surface. So it is not specific, and it is multimolecular layer. So there is formation of different layers. क्या होता है, फर्स्ट लेयर फॉर्म होता है, देन सेकंड लेयर फॉर्म हो जाता है गैस का. तो ऐसे बहुत से सारे मल्टी लेयर फॉर्मेशन हो जाता है. सो इट इज इरिवर्सिबल इन नेचर, it is reversible in nature, it is not specific, and it is multimolecular in nature. While in case of chemical adsorption or chemisorption, it is irreversible in nature. Why it is irreversible in nature? Because there is formation of chemical bond. Chemical bond form हुआ है, covalent bond form हुआ है, sigma bond form हुआ है. So it is irreversible in nature. It is highly specific. It is highly specific because the presence of chemical bond. So this chemical bond is specific in nature. So it is, these types of adsorption is also specific in nature, and it is monomolecular layer. So it is not a multi-layer phenomenon. It is a monomolecular layer phenomenon. Okay, so this is the second difference. Then third difference क्या है? It usually takes place at low temperature. It usually takes place at low temperature. So this physical or van der Waal adsorption takes place at low temperature, and it decreases with increasing temperature. So with increasing temperature, what happens? These van der Waal forces, they get breaks. With increasing temperature, van der Waal forces, they get breaks, and due to this increasing temperature, this physical adsorption also decreases. Now in case of chemical adsorption or chemisorption, it usually takes place at low temperature. It also takes place at low temperature. So both these phenomena, third point is quite similar. So both the phenomenon, that is chemical adsorption and physical adsorption, that takes place at a low temperature. This is common point between these two types of adsorption. Then fourth type one, enthalpy of adsorption is low. Why enthalpy of adsorption is low? Because the forces are weak. Forces are weak. So due to these weak forces, enthalpy of adsorption is also low, and the range of enthalpy is 20 to 40 kilojoule per mole. The range of enthalpy in case of physical or van der Waals adsorption is 20 to 40 kilojoule per mole. While in case of chemical adsorption, enthalpy of adsorption is very high. Why enthalpy of adsorption is very high? Because chemical bond, because the presence of chemical bond. Due to this formation of chemical bond, enthalpy of adsorption in case of chemical adsorption is very high, and the range for enthalpy is 40 to 400 kilojoules per mole. The range is 40 to 400 kilojoule per mole. आप लोगों को दिख नहीं रहा होगा शायद. I will write here 40 to 400 kilojoule per mole. And the fifth point is, normally it does not involve any energy of activation. So to form van der Waals bond or van der Waals interaction, there is no need of energy of activation, because it is a weak interaction, So in case of physical or van der Waals adsorption, energy of activation does not require. In case of physical or van der Waals adsorption, energy of activation does not require. Now in chemical or chemisorption, it requires energy of activation. We have seen in the last chapter, that is to form a excited state or activated complex, it requires energy of activation. Then and then only that reactant molecule, they get converted into the product molecule, that we have seen in the last lecture. So chemical adsorption or chemisorption requires energy of activation, while physical or van der Waals adsorption does not require energy of activation. So these are some characteristics of physical or chemical adsorption. Okay, then we will go to the next very important point, that is adsorption isotherm. So we will see the different adsorption isotherm. First adsorption isotherm we will see, that is Friend-Lewis. Second, that is we will see in Langmuir adsorption isotherm, and third is BET adsorption isotherm, capital BET. Third one is capital BET. So these three adsorption isotherms are there: Friend-Lewis, Langmuir, and BET. Okay, so before going to that particular adsorption isotherm, first we will see what is adsorption isotherm. ये क्या होता है adsorption isotherm? So it is a relation. क्या है? It is a relation of relation in between temperature and amount of substance adsorbed and the pressure or concentration. So it is a relation in between amount of substance adsorbed and temperature and pressure. So that relation is called as a adsorption isotherm. So let us see the definition of adsorption isotherm first. If you have pen notebook, you can write down this definition. The relation at constant temperature, and that relation is at constant temperature. जो कुछ भी हम लोग relation दिखाने वाले हैं ना, that relation should be at constant temperature. Please remember this. So it is the relation at constant temperature between the amount of substance adsorbed by a substance or a solid substance and the pressure or concentration at equilibrium is called as adsorption isotherm. So two important points are there. So it is a relation at constant temperature and at equilibrium. It is a relation of amount of substance adsorbed by a solid substance at constant temperature and at equilibrium. So it is called as a adsorption isotherm. I will repeat this. The relation at constant temperature between the amount of substance adsorbed by a solid substance and the pressure or concentration at the equilibrium is called as adsorption isotherm. And first adsorption isotherm we will see, that is Friend-Lewis isotherm. फर्स्ट हम लोग देखेंगे दैट इज फ्रेंडलिच आइसोथर्म, ठीक है। सो दिस फ्रेंडलिच आइसोथर्म it is nothing but it is an empirical equation. क्या है? It is a equation for the variation of extent of adsorption with pressure at constant temperature. So in this Freundlich isotherm, variation of adsorption is given. In the Freundlich isotherm, variation of extent of adsorption is given with pressure at a constant temperature. So in this Freundlich, it is the name of scientist who proposed these isotherms, and he has given the relation or he has given the relation extent of adsorption with pressure at constant temperature. मतलब प्रेशर के हिसाब से एब्सॉर्प्शन में क्या चेंजेस होते हैं एट कांस्टेंट टेम्परेचर, दैट relation is called as a Freundlich isotherm. That relation is called as a Freundlich isotherm. Let us see the equation first. So here x by m, so it is empirical equation. X by m is equal to k capital P 1 by n. This is our equation number 1. Now in this equation, x is what? In this equation, x is mass of gas adsorbed. So x is nothing but the mass. किसका मास है? गैस एडसॉर्ब. Whatever the gas is adsorbed, जो कुछ भी गैस एडसॉर्ब हुआ है उसका मास, that is indicated by x. Then m, what is m? m is mass of adsorbent. जिसके ऊपर एडसॉर्ब हुआ है ना उसका मास. m is mass of adsorbent. p is equilibrium pressure. And k and n, these two are empirical constant. So these adsorption isotherm, or this equation is called as a Freundlich adsorption isotherm. X by m equals to k, p raised to 1 by n, and here x is mass of the gas adsorbed, m is mass of adsorbent, p is equilibrium pressure, k and n are empirical constant. So it is called as a Freundlich adsorption isotherm. ठीक है. Now in the equation 1, please remember this. In equation 1, n is greater than 1. जो कुछ हम लोगों ने equation 1 देखा ना अभी उसमें जो n है, it is always greater than 1. Please remember this. n क्या है? It is always greater than 1. Therefore what happens? The amount of adsorbent and adsorbate increases less rapidly than the pressure. Due to this, what happens? Amount of adsorbent and adsorbate increases less rapidly with the pressure than the pressure. ठीक है. And when the adsorption of solute from the solvent. Now here जो first equation हम लोगों ने देखा था ना, वो when the two phases are solid and gas. That first equation ये वाला, it is applicable to the when the two phases are solid and gas. That means your adsorbent is solid and your adsorbate is gases. It is applicable for this solid and gas. Now when the two phases are liquid and gas, or liquid in liquid, solid in liquid, then this equation is written. Only difference is that in the first equation here P was there, and instead of P in this equation C, capital C is there. So here x by m is equal to k, c raised to n by 1 by l. Now here x is again same, mass of gas adsorbate, m is mass of adsorbent, c is concentration of adsorbed substance. Here only instead of pressure concentration term is there. And k and n are, you know that it is a empirical constant. So when the solute is adsorbed from the solvent, this equation you have to use. ठीक है. Okay, चलो. Then next point is the equation 1 जो हम लोगों ने देखा था can be graphically written as. So equation 1 हम लोगों ने देखा था ना, उसका हम लोगों ने अगर हम लोग उसको graphically represent करना चाहेंगे तो कैसे करेंगे? Let us see here. I will draw the graph first. For example, this is your y-axis and this is your x-axis. So we'll represent that equation 1 by a graph. This is y-axis and this is x-axis. Now on y-axis x by m is there. Let us on y-axis x by m is there, and on x-axis pressure is there. On x-axis pressure is there. Now if you plot a graph x by m versus pressure, then it will come like this. Yeah, ऐसा आ जाएगा. Now here, for example, let us see up to this pressure. Let us say up to this pressure. That means this pressure is here, 0 is there. So this up to this pressure is low. So at the low pressure, x by m, see here, as we increase the pressure, so it increases up to this point. Okay, so we can say that at low pressure, x by m is directly proportional to the pressure. So at the low pressure, जब प्रेशर कम होता है ना, तो x by m increases with pressure. X by m increases with pressure. So at low pressure, x by m is directly proportional to the pressure. So this happens at low pressure. Please remember this. This happens at low pressure. Now let us see. Let us take here. Okay. So up to this. So from 0 to this pressure, this is intermediate pressure. So it is intermediate pressure, and this क्या होता है अभी? It is not directly proportional. So x by m is directly proportional to the 1 by n. X by m is directly proportional to the 1 by m, and from this pressure, that means this region is high pressure region. This region is high pressure region, and this high pressure region x by m remains constant. See here, so this value it remains constant. See here, so this value remains constant. So x by m at high pressure is equals to constant. So this is at intermediate pressure. And this at high pressure, x by m remains constant. It is at high pressure. So this is called as a Freundlich adsorption isotherm. It is called as Freundlich adsorption isotherm. If you write that equation 1 graphically, then this information you can gain from that graph. Then, and if you take the log of both side of the equation, by taking the log of both side of equation, we will get this equation. If you take log of both side, then you will come to log of x by m. Here this 1 by n is constant, so we will take that 1 by n term before the log. So n by 1 is constant, so we'll keep outside the log, so log p plus log k. And if you see this equation, it is in the form of y is equal to mx plus c. Y is equal to mx plus c. And if we plot the graph, log x by m versus log p, then it will be like this. If we plot a graph, this is your x-axis and this is your y-axis. This y-axis पे क्या लेंगे हम? x by m, log of x by m लेंगे, and this is your x-axis. x-axis पे क्या लेंगे हम लोग? We will take log p. And if you see this 1 by n, it is a slope, and slope is positive. So the nature of the reaction, and this c is intercept on y-axis, log k. So it will, the nature of graph is like this. And if you take slope is equal to what? Slope is this term 1 by n. Here in this equation, m is slope. So slope is equal to 1 by n. And intercept on y-axis will be equal to log k. So we can find out this constant, that is 1 by n by using the slope. Now this Friendly's adsorption isotherm, हम लोगों ने अभी जो देखी है, it is applied for very limited range of pressure and concentration. While if the pressure and concentration is very high, then this adsorption isotherm does not give you accurate result. So it fails at high pressure and concentration. So this Friendly's adsorption isotherm is applicable to a very limited range of pressure and concentration. Because of at high temperature what happens, it fails to give you a correct result. Because of at high concentration, it fails to give you a correct result. ठीक है? So with this I think we will stop here. ठीक है, हम लोग यहाँ पे रुक जाते हैं. If you have any problem, any doubt, you can ask me. If you don't have any problem, any doubt, then it is good. ठीक है? So tell me, have you understand this today's lecture? Have you understand this or not? बोलो जल्दी से. अरे सबको समझ में आया? अच्छी बात है. कहाँ पे है? Everyone is saying yes sir, yes sir. ओके चला. रुपेश कुमार is saying understood sir. अच्छी बात है. Only Rupesh Kumar is saying yes sir. What about others? I can't see your chat. What happened to my phone? Okay, Shivani station. Now I can see. Rupesh Kumar is saying understood sir. Okay, ठीक है. Now if you don't have any problem, then you can give the attendance. You can give the attendance. We will stop here. ठीक है. Shall I stop the lecture? Shall I stop here now? Shall I stop here or not? Okay, Rupesh Kumar is saying yes sir. So I will Pramodini Nutan. Very good. Chalo. So take care. Bye bye. Have a good day.